Okay, I need to talk about. Okay, I want to talk about this new acronym called RATTEY. R-A-T-T-E-Y. R stands for roots. A stands for asymptotes, horizontal and vertical. T stands for tangency. The other T is for togetherness, and E is for in behavior, which is basically dealing with our horizontal asymptotes. Where does our graph, what Y value does our graph seek? And then we've got Y is for Y-intercept. Okay? Let's go over, real quick, I want to cover tangency. We've covered this before. It basically deals with the numerator. So up here I've got x squared minus 4x minus 12. That'll factor as negative x minus 6 and x plus 2. Both of these factors in the numerator, we want to set the numerator equal to 0 and find out what our zeros or x-intercepts are. What are the values at x that give us a y value of 0? Remember, y values of 0 are always determined in the numerator. Okay, we've been doing this. So I factor the numerator. Either x is 6, 6 minus 6 is 0, and which makes 0 times anything is 0, or negative 2 plus 2 is 0, and then 0 times anything is 0. So those are my roots. 6 and negative 2. But remember what the word multiplicity means. These are all, when we factor things, this factor occurs 1 to the first power. It's okay? Whenever your multiplicity, its exponent is odd, remember, we don't have tangency. In this case, we're going to go, the graph goes through that x-intercept. Okay? Goes through it. Okay? So anytime your multiplicity, how many times is that factor multiplied? Well, it's only one time, and here it's only one time. That's an odd exponent. So that's when you go through your root. 2 and I think I did this wrong. I had a bit. I got this backwards. But in any case, this is supposed to be. Let's do it the right way. Anyway, here's your asymptote of negative 2, and here's 6. Okay, but oh, geez, I'm brain dead, the guys. Brain dead. Anyway, this is supposed to be 6 and negative 2. I've got them flip-flop. But in any event, whenever your factor is odd, you go through and you don't bounce. You remember the bounce? That's what tangency means. So in here I got it right. My numerator is x plus 6, x squared plus 6x plus 9. This numerator factors as x plus 3. So my 0 or x-intercept would be negative 3. Good Lord, I'm brain dead. So that's where it should be. It's going to hit this and bounce off, okay? Whenever your multiplicity is even, it's squared to the 4th power. This factor that creates my 0, whenever it's even, it's going to bounce off, okay? That's tangency. This creates, it's just tangent on the x-axis, okay? All right? So anytime your factors are multiplicity of odd, like 1, 3, it's going to go, they go through the graph goes through that x-axis at that root. Okay? All right, enough on tangency. I have 3 minutes already. Togetherness. This togetherness is a denominator function. Denominator, okay? All right, remember, we get our domain from the denominator, the things that we can't have happen because we don't want undefined functions. So here, x can't be 2, and here, x can't be 3 or negative 4. Okay? So, let's say nothing's removable. I don't have any removable discontinuities, so I've got some, here I'll have an asymptote at 2. 2 minus 2 is 0, so my domain says x can't be 2, so my vertical asymptote is x equals 2, okay? So here's my vertical asymptote. If the factor that creates the vertical asymptote is squared, or an even exponent, the graph, as the graph hits that exponent, the graphs from either side, they move together. Notice how they both are increasing. Or they could be maybe decreasing. But notice how when you approach the asymptote from either side, they go together. Okay? So if your asymptote comes from a factor that's squared or to the 4th power or an even power, your graph moves together at the asymptote. Here's a case where my denominator 3 and negative 4 are not in the domain. X can't be 3 and negative 4. So that's exactly what my asymptotes are. X equals 3, X equals negative 4. And notice how I've graphed those. But notice they only occur, they're not squared, they're odd. They're just, like odd multiplicity, okay? In that case, your graphs will move in different directions, okay? So if this graph comes up and approaches like this, well, then I know what this graph's going to go in the opposite direction, okay? And I also kind of know if I have a horizontal asymptote, outside of my vertical asymptotes is where the graph seeks its end behavior, and it'll come, and you can graph it accordingly. So I know this one, we might have had an x-intercept, so I know I've got to go through and so forth. But we'll learn how to graph, okay? The big thing is togetherness, okay? If it's odd multiplicity, like I said, this is just x minus 3 to the first power. The graph at that asymptote that's created there, like at 3 and negative 4, notice how the graphs are not, they're apart, okay? As they approach the asymptote from either side, they go in different directions. Where if you come from a squared or an even, the graphs approach that asymptote that's created by that and work together. All right, so here's a problem. We'll really quickly go through. X plus 1 over x squared plus 4x. I simplified this. I factored out an x. So my roots are in the numerator, okay? So this is I set my numerator equal to 0 and solve. Obviously, x plus 1 equals 0, then x is negative 1. That's my only x-intercept, okay? And that's important, okay, at negative 1. All right, asymptotes, horizontal. We've got bigger on bottom, 0, bigger on top, none, Bobo Botten, and each DC is exponents are the same, divide the coefficient. Bigger on bottom, that's 1, that's 2, so I have a horizontal asymptote of y equals 0, that's Bobo, x-axis, right? My vertical asymptotes I get from the denominator and the domain, okay? All right, so I factored this, simplified this, and notice nothing crosses out. There's no removable discontinuities, okay? So both these factors would create a vertical asymptote. So in my domain, x can't be 0. I can't have this x be 0, and I can't have x be negative 4. So my domain is such that x can't be, I have all values of x such that x can't be 0 or negative 4. Therefore, my asymptotes, my vertical asymptotes are x equals 0 and x equals negative 4. Okay? And you can see how I'll have that graph. There's my vertical asymptotes. Okay? At 0 and negative 4. All right? Tangency. Okay? Notice my x-intercept comes from x plus 1, and it only happens one time, right? It's only a factor of multiplicity one time. It's not squared. So at that x-intercept, we will not bounce. We're not going to bounce. There's no tangency. It's no bounce. Okay, we're going to go through the x-axis at that point. Okay, we're not going to bounce. Togetherness, the denominator. Okay, let me just bloom. Right. Again, both these factors that create my vertical asymptotes are not squared or an even power. So the graphs will move separately, or they'll move apart, up or down or so forth. They're not going to move together at those asymptotes, all right? My end behavior, outside of my asymptotes, they'll eventually seek the horizontal asymptote of y equals 0, okay? All right? And then y-intercept, basically we're not going to have one. Why? Because we need to put in 0 to get a y-intercept, right? And I plug in 0 for x to get your y-intercept, right? Here's the y-axis, x is 0. Well, if I put in 0, I get 0 plus 1 is 1, but down below I get 0, so it's undefined. Guess what? Remember, 0 is not in our domain. We have an asymptote there, right? So there is no y-intercept, okay? All right. Here's our graph of that function. All right, I know at all my asymptotes, the graphs are going to go in different directions. All you really need to do is kind of start at one place. I plugged in 1 here to the equation, okay? I know the only place I'm going to cross the x-axis is x equals 1. That's the only x-intercept we have, okay, or -1, I'm sorry, -1. At x equals -1, that's the only place, okay, and there it is right here, okay. So nowhere else are we going to cross or even touch the x-axis, okay. So I plugged in 1 just for a value, and I got 1 plus 1 is 2, and then I plugged in 1 plus 4 is 5, and 1 times 5 is 5. So it ends up being 2/5. That's positive, okay? This is to the right, to the outside, and I know my in behavior, I'm going to seek the horizontal asymptote because I am Bobo. This in behavior approaches 0. And I know I approach this, as I approach this asymptote, I have nowhere else to go but to go up. Because I'm not, for me to go down, I'd have to cross the x-axis, and I know I don't. Here's the only x-intercept I have. So I know at approach 0, as x approaches infinity, the graph approaches a y value of 0, the horizontal asymptote, and I'll hit this point, and obviously I'm going up. So now I know this graph has to go down. Okay, because these graphs are apart. Why? Because of the togetherness. The vertical asymptotes that were created, none of them are squared. Okay, so I hit my x-intercept, and I know that I can't come back down. I only cross this once, and it's going to go up here. So it'll hit this asymptote and go up, which means I know, again, this asymptote does not act together. This asymptote was formed by the... this denominator of came from x plus 4, so it's -4. So this is going up again, no togetherness. So this is going to go down, and this will seek the horizontal asymptote of the x-axis, or y equals 0 for the end behavior. So that's kind of how we're going to graph things. Tomorrow we'll work some more. The big thing is RADI, and again, roots from the numerator. Set them equal to the numerator equal to 0 and find your x-intercepts. The asymptotes from Bobo, Bodden, each dz for horizontal, vertical, you get them from the denominator. Tangency is your numerator, it's your roots. If they're even multiplicity, they bounce. If they're not, they go through. Togetherness is your vertical asymptotes, the factors that create them. If it's squared, the graph acts together, like so. If it's not, then they act apart like that, okay? In behavior is your horizontal asymptotes. It deals with the horizontal asymptote. What does your graph seek after it's at the very outside of the graphs, and your y-intercept we talked about? All right, that's it. We'll see you tomorrow if it's not a snow day.